Hello everyone. I hope that you are fine. In this lab, we shall learn how to make maps manually. In the second lecture of robotics, we studied about discrete maps and their advantages. So today we shall implement. For this purpose, we shall use Matlab Software. And before starting the coding, I shall briefly go through the discrete maps concept. Okay, so what is a discrete map? Let's say this is our room. This is a 2D top view of our room, and there are some obstacles here. Let's say this is an obstacle. So this is the white space is a free space, and this lined space is an obstacle. So now the thing is how we can represent this environment or this room in a way that computers can understand. Okay, so we need a model. So we chose the discrete model. What we do here, we do the same thing with using a computer. Using you can say a tool that is understandable by a computer. So in this way, what we do, we divide this space, total space, into small cells, or you can say blocks. Okay, they are not equal. Let's try to make them equal. So there is 1, 2, and 3. And similarly the other way. 1, 2, 3. Okay. So when we represent the map of the real world in a discrete format, so then it means that these will be obstacles. These cells are blocked. They're not usable. You remember, even the partial, if an obstacle partially occupied any cell, it means the whole cell is occupied. Okay? So this is a rough representation of this room of the real world into a discrete map. So yeah, this is again a 2D map. It's a discrete. This is the occupied space, and it is represented by 1, and the other, they are all free spaces, and they are represented by 0, all of them. And yeah, they're also called binary maps. So binary means that they can be only two possibilities. Either a cell is occupied or it's not occupied. So that's why they are called binary maps also. And if you remember, I also told you about there is another type of maps that's called probabilistic maps. In probabilistic maps, there can be multiple possibilities of occupancy between the 0 and 1. So, for example, 0 means not occupied, then 0.5 means there is no knowledge, the robot is not sure whether there is an obstacle or not, and 1 means it is 100% surety that there is an obstacle. But for the simplicity, we shall only consider here the binary maps, 0 or 1. So it means obstacle is present or not present. So let's move to the Matlab software, and we shall write today a simple program in which we can create a map in the form of matrix, and then we also visualize this map graphically. So these are the two objectives of today's lab. So let's start. We write clear all. So every time when we run this code, so we clear the saved variables and also save this code also. Let's name it 2D map. Okay, so this is clear all, and then after that we shall start with defining the maximum size of your map. So we call it x max. We call it x max is equal to, let's say the map size is 10. So this is the size of the map on the x coordinate, and similarly we shall define. Okay, let me comment it so it will be easier to map on x coordinate, x-axis you can say. And then we have size of map along y-axis. For that we write y max is equal to, let's say this is also 10 meters, let's say. Okay, so once we have this, then we define here what is the what are the locations of the start and the target position. Okay, so x coordinate of start position, we call it, okay, xs, and this is equal to, we call it, let's say this is 1. Now we have y coordinate of the start position, call it y of s, and this is also equal to 1. So the x and y of the start point are the 1 in the map. After that, we shall define the x and y, x coordinates of the target point, and we say it x of x underscore t is equal to, let's say this is a 10, and then we say that the y coordinate of the target point, so y underscore t is equal to 10. So up to here we have defined the maximum size of map, the coordinates of the start point, and the coordinates of the target point. Okay, now we define actually the map, what we call it. Okay, map map is equal to zeros. So what we want to do when we say map, it means in a computer it means a 2D matrix with rows and columns. Okay, so map, what I'm going to do, I'm here creating a map, and I shall fill this map with zeros. It means that initially there will be a free space everywhere in this map, and of course it will be a discrete map because I'm creating here a matrix. So matrix is already a discrete. Okay, so zeros, it will create a matrix filled with zeros, and the size of this matrix will be the size of the map we have created, x max and y max. So let's write down here x underscore max and y underscore max. So now this command will create a matrix filled with zeros. Okay, so for simplicity I also write down here create a matrix filled with zeros. So this map will be a matrix. Okay, after that, in the next step, I shall define the location and the size of obstacle. Okay, so let's define the obstacle origin. Obstacle's origin. And the origin of the obstacle is, let's say we have 3 on the x-axis and 3 on the y-axis. Okay, so this is the start position of the obstacle, and now we shall define the size of the obstacle. Obstacle size is equal to, let's say this is 5 meters along the x-axis and 5 meters along the y-axis. So it means that it will start from x-axis 3, y-axis 3, and its total size will be 3 plus 5, 8 and 8. So it will go till 8 meter toward the x-axis and 8 meters toward the y-axis. Notice that we have to, because we have our grid is a cell, a square cell. So here we need to also make obstacles that are square, okay, because we have to fill those cells. So there should be a symmetry between the size of the obstacle. If they are unsymmetrical, then it will not fill a cell completely. It will partially fill the cell. Okay, up to here we have also created an obstacle origin and also its size. And now it's time to fill the map with obstacles. So we now know that where the obstacles, what is the size and location of an obstacle, and now we shall fill our map with these obstacles, because our map is empty till yet. Map only contains 0, and 0 means free space. Okay, so now fill the map with the obstacle. So for that we need a for loop. Let's say for I is equal to obstacle origin and only its x coordinate. First we only take the x coordinate. Then this for loop will start from the origin of the obstacle, and it will go the maximum, the upper limit of this for loop will be the maximum coordinate of the obstacle, size of an obstacle. So what is in size of this obstacle along the x coordinate? This was the origin, this is x coordinate, okay, this one here. This was the origin of the obstacle along x coordinate, and this is the size of the obstacle along x coordinate. So 3 plus 5 is equal to 8. It means this obstacle will be 8 meters along the x-axis. So what we did, we just added 3 plus 5. So it means the x coordinate of obstacle origin, so we call it obstacle origin, and its x coordinate only, and we add it with the obstacle size, this one here, obstacle size, its x coordinate only. So one means the first element of this vector, or you can say this array. So the first one is x-axis and y-axis, x-axis and y-axis. So this for loop will start from the origin of the obstacle, and it will go till the maximum length of an obstacle. So if you are still not clear about this, I can make something like this. For example, this is your map, and this is your x-axis, and this is y-axis, and this is the obstacle origin. Okay, and let's say it's 3 here, and this is y-axis, y coordinate, and this is also 3, and the size of obstacle is along x-axis it's 5, this length is 5 actually, and along y-axis this is also 5, 5 and 5. Okay, so what will be the total length along x-axis? It will be this length 3 and plus 5. So this length plus this length here, this is 5, and total length will be 8 along x-axis. Okay, and same is true for, we can calculate for the y-axis also. Okay, so that's why we use this for loop, and then we shall use again one more for loop for the y-axis, and this loop will be start from obstacle origin, but this time it will be its second coordinate, second element, or the y-axis, and it will repeat till the end of the obstacle. So we call it obstacle origin. I think here the spellings are wrong. Origin, obstacle origin, y-axis plus obstacle size, and its y-axis. So this was for the to fill the map with both x and y-axis, and here actually the filling process is here. Map is equal to, so this was our map actually, which is till now it is filled with zeros. It means it is a matrix which is filled with zeros. If you want to see how it looks like, so I can write down here, let's say map is equal to zeros, and let's say 10 is the x component, y component, and then when I enter it, so here you will see, after executing this command, it has created a map of 10 rows and 10 columns, and they are all zeros. So this can be considered as a map because it's discrete, and it can represent a grid map, but actually it is a matrix. So what we do, we try to model our environment in such a way that it is understandable by the computers also. But computers only understand the digital or the discrete or the matrix input data. Okay, so now we shall start filling the location of obstacles in these cells. So what we do, we write down here, let's say I and j. This will be the coordinates of this will be the row and columns of the matrix. Sorry, not equal to. Now this is, so this matrix map, its rows and columns is equal to 1. But when it will be 1? From the beginning of the obstacle till the end of the obstacle. Okay, so it means that it will fill, if obstacles start from 3, it means 1, 2, 3 and 1, 2, 3. So from here to here, 5, 1, 2, 3, 4, 5, 1, 2, 3. Okay, not. So it will fill the obstacle in this way with 1. So 1 means here will be an obstacle. Okay, and similarly along the y-axis or the columns also. So we end these for loops first to complete them. Okay, now our obstacle filling process is complete. So now we have a map which has a free space, which also has an occupied space by obstacles. And now two more things we needed. We need a location of our start point, and also a location of our target point. So let's fill this also manually. So we call it map is equal to map of x underscore s and y underscore s is equal to 2. Let me write down a comment here also. Fill the map with the start point. So the start point, we see this, we took the matrix and we on this row we have given the coordinates of our start points, the x coordinate, and in this column, in the place of column, we have given the coordinates of our start point, the y component. So we want that in this location of the matrix, this element should be replaced by 2. Previously it was 0, or maybe it was 0, because the start point can only be on the free space. So previously it was 0, and now we want to be 0 replaced by 2. Similarly, what we do, we shall fill the map with the target position, a target point, we can say. So this time we give the coordinates here, the location of our target, which was 10 and 10. Let's say we give it t underscore x and t underscore y is equal to 3, because we have to differentiate between the map and the target. Sorry, the start point and the target point. So that's why we given 2 and 3. Okay, till now we have a map which is filled with zeros, and also it has location of obstacles, and also the start and the target point location. So now what we're going to do is we shall plot. We want to plot this thing, so it's also visually available to the user. So let's plot it. Plot the map along with obstacle, start point, and target point. So for this purpose, we just make first a figure, and in this figure we turn on the grid, because we have to visually show that this is a discrete map. Okay, so we need a grid on, and then also hold on. So hold on means that the previous drawings or the previous results will also be saved on the map, on the figure. So now we shall use a command in the MATLAB. It's called patch. So in the patch, what we do is we make some kind of objects, and then we fill these objects with colors. Okay, so this is, here we can say draw the obstacle using patch command. So this command is like this, P-A-T-C-H, patch, and then we have to give the x coordinates of the four corners of the obstacle. So let me show you here, maybe. Okay, so these are, our obstacle looks like this with 4 corners. Okay, 1, 2, 3, and 4. So what was the location of these 4 points? Is first 1, 2, 3, 4. The first one was x-axis was 3, and also the y-axis was 3. For second, x-axis was 3 plus 5, 8, but y-axis was 3. For the third point, we have the x-axis was 3, and the y-axis was 3 plus 5, 8. And for the fourth point here, we have the x-axis is equal to 3 plus 5 is equal to 8, and similarly the y-axis was 8. So this is how we use the patch command. So in the patch command, we first give the x coordinates, and then we give the y coordinates of all these 4 points. Okay, and then we use the patch command, and it will fill this, it will make this box and then fill it with color, so it looks like some kind of filled obstacle. Okay, so if you remember what was the coordinates of our the first point. The first point was the origin of the obstacle, so we call it obstacle origin, and this is x-axis, because first we only give the x-axis, and then we give the y-axis. So first only the x coordinates. So it was obstacle origin 1. Okay, and then we have the second point was, so in obstacle origin 1 here we have, if you remember, we have here 3, the x coordinate of here. You can see this one, we're giving it 3 here. So this is 3. And after that we give the x coordinate of the second point, and this is the obstacle origin x coordinate plus obstacle size x coordinate. So this is the the x coordinate of the second point. So this is 3 and this is 5. 3 and 5. If you want to look visually, then this will be like this is our second point. So we want to calculate this one here, this thing, and it will be 3 plus 5, 8. Okay, so now we have calculated the x coordinate of the second point. Now it's time to calculate the coordinates of our third point here, this one, this point here. So which will be the x component is 3 just. So which is understandable, which is the obstacle origin 1, first element here. And then after that, the x coordinate of our fourth point, which is here, this is 8. So again it will be 3 plus 5. So it will be obstacle origin x coordinate plus obstacle size x coordinate. So this is the total 4 x coordinate of the 4 points of the obstacle. So this is the first point here, x coordinate of the first point, this is the x coordinate of the second point, this is the x coordinate of the third point, and this is the x coordinate of the fourth point. So these are all 4 x coordinates. And now it's time to give the y coordinates of all these points. Okay, so for the y coordinates, we shall again see the figure how. So you can see they are symmetric here also. So the y coordinates here is, this is 3, and then for the second point it's 3. For the third point it's 8, and for the fourth point it's 8. So 3, 3, 8, 8. So let's see how can we. So 3 means the y coordinate, the second one. So this time obstacle origin with this coordinate here. This time it will be 2. Again. And now so these are the y coordinates of the first 2 points. So this will be 3 plus 5. But this time it's along y-axis, so I've put in here 2 and 2, and again Okay, so here we have completed this command for to visually draw the obstacle, and now we just have to visualize to draw the location of the start point and the target point. So we shall do that. Draw the location of start point. So for this we use a command, it's called scatter. So you remember what were the coordinates of the start point? They were like x underscore s x underscore s, and then y underscore s, and let's put what kind of object we want to put here for visualization. Let's put O. This will be the shape that will be displayed on the map. And we can also define the color here. So let's define its color red, and then we make it filled. So this O will be filled with red color for better visualization. Okay, this was the visualization of our start point, and similarly we can also draw the target point. We shall again use scatter command here. This time we give t underscore x, t underscore y. Okay, and again we shall use O, circle, and the color will be, this time let's say make it green, and of course it should be filled. So let's make it filled. Okay, so now to perfectly align all the cells and to make the cells equal and on a fixed size, we use this command, grid cell fixed size, fixed length, or you can say. So we use this command that's called set GCA, and then it's xtick, T-I-C-K, xtick, comma, it will start from 0 and with a size of 1. It will go to the maximum size of your map. What was the maximum size? X max and Y max, yeah. So which is 10. So X max. So this will be along X axis, and then same we repeat for Y axis also. This we call it Y tick. Start from 0 with a size of 1 and end with till Y max. Okay, so this is the fixed size grid, If you don't make it fixed, then the MATLAB automatically select the appropriate size depending upon your screen size or the resolution, stuff like this. So it can easily fit on your screen. But using these two commands, we can manually give it custom size. Okay, now we shall give the start and the ending of our axis. Using this command, it's called axis, and then you have to give here the beginning coordinate of the x-axis and then the end of it, and is the x max. And similarly, for y-axis we want to start it from 0 and it should go till y max. Okay, so this is our code, and let's try to run it and let's see the results. And before that, we already have this map, so let's finish this one. Let me clear all. We cleared everything, and okay, let's not do this one. Okay, let's try to run this and see the results. Okay, it seems like there is a problem with the name, and okay, spelling mistake we have here. Origin, yes, that's for sure. Okay, I have corrected it, and let's see if there are some others. Yes, of course. So we haven't defined t_x. I think we have defined it, or also it was another way, x_t, not t_x. Okay. And y_t. Oh, so many errors. Okay, so not enough. Okay, so this error says that not enough input arguments in this command patch. So it shows some kind of error, and we have given the x-axis, y-axis, and yes, we also need to give the color, which color we want to give. So let's give it here the black color, which is represented by K. So now I hope that arguments will be enough. So it shows something like this, which is of course not what was intended. So it means there are still some errors. So let's see what errors we more have here. Okay, it says, so yes, I mix them. It's x_t and y_t. Okay, so this is what it looks like, but this is not what it should be, because the obstacle should be a square. It has to fill these cells completely. You see here there's a partial filling, then this doesn't work in the grid-based maps. So there is an error, and we have to find out quickly where the error is. But at least you have got some idea how it works, how it looks like. And so this is our start point, and this is the target point, and this is purely 2D. This is just a plane. There is no height. You can see it's just the obstacle is 2D. So yeah. So let's fix the errors what we have here. So the visual representation of the obstacle is wrong, and I think the problem is how we define the points, and that was a little bit misarranged actually. So this is let me make it with green. This is the first point, this is second point we call it, and then we said this is the third point, but it's not true. Actually this is the third point, and then this will be 4 point to make a square. Okay, so if we use this one, the third point, and this is the fourth point, then it will make something like this. And yes, that's why we were looking something like this. So now let's give the coordinates like this: first point, second point, third point, and fourth point. And let's see the results. So the first point is the origin, which is the x coordinate is 3, and then we have second point here, 3 plus 5, 8, and this was the second point. Okay, and then we have the third point, which is again the 3 plus 5. So if you see the third point coordinates, it will be, this is third point, so it will be 3 plus 5. So this is 5 here. The length is 5. Should I write the length here like this? 5. And this is already 3. The length is 3. This is 3. And this is 5. The total is, so both of these points, second and third, it has the length of 3 plus 5 is equal to 8. They both have 8. So it means that we have written it wrong here. So let's correct it. So it will be obstacle origin plus obstacle size. It's x-axis only, and from here and the coordinate of the fourth point is, if you see the coordinates of the fourth point, this one here, it has only x-axis is equal to 3, which is the origin of the obstacle. So we have to make it here, we have to, sorry, so this is the fourth point. We have to remove the size of the obstacle here, only the origin here. So this is the correct format we have here. And now for the y coordinates of all these 4 points, they should be, let's see again how the y coordinates will look like. So it will be 3, again it will be 3, 8, 8, 3, 3, 8, 8. So let's see here what we have written here. Obstacle origin y coordinate, which is 3. And then we have obstacle origin y coordinate, which is 3, and then obstacle origin y coordinate plus size 3 plus 5 is equal to 8, and then we have obstacle origin y coordinate plus its size 3 plus 5 8. So this time it looks okay, and let's confirm it by running the code. So yes, it's so this is what was expected, what was desired, and this is, you can see, 2D, a 2D map we have. One more thing that it need to be corrected is that these points, the start and the target point, they are on the edges of or the corners of the cell, which is not normally the case. They should be represented somewhere in the middle of the cell, somewhere here or maybe somewhere here, but it should not be on the corner, okay, because it's a discretized representation. So what we have to do here, we have to just add here or subtract, maybe. Where is the representation of the start point? We have to subtract from here 0.5 from x-axis and minus 0.5 from the y-axis. And same is true we do with the target point, minus 0.5 and minus 0.5. So let's run it. So yes, so now this is the first cell, and this whole is a grid, and this is a cell for the target, and this is obstacle we have here. It starts from 3, x-axis 3, y-axis 3, and it ends at 8 and 8. So both its size has 5 along x-axis and 5 along y-axis. And notice that in this cell from 0 to 1, it means all is 1 here. All cell it's considered the first cell from 0 to 1. And from 9 to 10, it's actually 10. Okay, this cell is 10. So when we say that, okay, this point is located in the 10th cell, it doesn't mean that there is a specific location. It means the whole cell is covered by this thing. Okay, in reality, it should be displayed like full square, like this. This whole cell should be colored with green color, and this whole cell should be covered with red color. So this is the accurate description. But since it's understandable, so we just let it like this. And now this is the visual representation of the map, a 2D map. And let's see how computer understand this map in the form of matrix. So let's see the matrix we have here. And this is in our workspace. We have a couple of variables, and this is one of them, which is map. So this is the matrix of the map. And as you can see, in the first column, first row, we have 2, which is the start point. And then we have zeros, which shows the free space where the robot can move around freely. And then we have 0 here. These are the, you can say, this is the obstacle. Okay, starting from 3 going till 8. And then this is the final target point here. So this is understandable by the computer. It is a binary representation of the map of the real world map, zeros or ones. And then what's the purpose of doing all this stuff is that later we can do path planning. For example, if we want a robot move from start point, and then it moves somewhere, like it wants to go to the target point and avoiding the obstacles. So we shall use some algorithms for path planning. So it avoids the obstacles and reach the this target point. Okay, I hope that this is clear. And yeah, here you can see also this is a visual representation. The robot can move here, avoid the obstacle, only follow the empty free space, and then reach the target position. Okay, so this experiment is finished. The code is, I shall also send you the code, this Matlab code, and what you have to do is you have to make a map by yourself in Matlab by using the there should be two obstacles, and also try to make a 3D version of this map also. So this was a 2D version, and just try to make a 3D version of this map and see how it looks like. So I will make here how your map should look like. Okay, this is your workspace, or you can say your 2D room, and this is the x-axis and this is y-axis here. So you have to make two obstacles. One should be its length should be, along x-axis it should be 2, this length, and here it should be 4, and the second obstacle should be a square obstacle, and its length should be, again, we call it 2 and 2 by 2, and the whole size of the map should be 10 along the x-axis, and maximum size will be here also 10. And the location of your target point T should be somewhere here, and let's say it's like 9. The coordinate should be 9 and 5, and the start point should be somewhere here, and its coordinate should be 2 and 5. So these two obstacles you can place anywhere. The origin can be anywhere. It's up to you where you want to put them. Better make it in the middle, somewhere middle, like the origin can be, let's say, so here is 3 along x-axis and 3 along y-axis. This is the origin of this point of the obstacle, and the origin of this point is the let's say here we have 7 along x-axis and 3 along y-axis, or let's say 2 along y-axis. So this will be the origin of your second obstacle. This is first obstacle. I should change the color maybe. this is obstacle number 1. I call it O1. This is obstacle number 2. I call it O2. This is your start point. This is your target point. And these are their locations in the space. So now you have to make a MATLAB code so you can visually draw this map, as well as also represent this map in a matrix form in MATLAB.